In this example, we want to determine where the function f of x equals e to the x times the factor x minus 3 on top, all over the factor x plus 1. We want to find out where that function is positive and where it's negative. Again, if we're going to use the intermediate value theorem to be able to determine this, we know that the only possible places where it could change from positive to negative or vice versa would be at places where it's either 0 or undefined. And so we've got to find that out first. Now f of x is already in nice factored form. So f is equal to 0 whenever the top is equal to 0. So we've got two factors on the top, e to the x and the x minus 3. We set each one of those factors equal to 0 using our zero product property and solve, and that would give us our solutions there. Well, e to the x equals 0 has no solution. Because e to the x, the graph of that is always above the x-axis, and so it never crosses the x-axis. I mean, if you were trying to solve this algebraically, to undo the e, we would take the natural log of both sides, but natural log of 0 is undefined, so there's no solution there that way either. So the other factor, x minus 3 equals 0, gives us x equals 3 as the root. So that's where f is 0. The other thing we have to pay attention to is where it is undefined. So that would be where the function is not continuous, and so we definitely have the possibility of changing from above to below or vice versa on the x-axis at a place of discontinuity. And so the function there is undefined whenever the bottom is undefined because you can't divide by 0, so we're talking x equals negative 1 when we set the factor x plus 1 equal to 0 and solve. So the two places that we need on this number line here to assess would be the negative 1 and the positive 3. So we get those in the right order. We put the tick marks there, and I'm going to go ahead and label my number line with f because it's the function f that we're assessing the signs for. So the test values that I'm going to be choosing here are going to be put in parentheses so that you know that they're not particularly important values. We need a value in the interval, but we could choose any value for each interval, and we'd get the same results. So that's why they're in parentheses. They're just to kind of help me remember what it is I'm plugging in, but it's not an important changeover place as far as signs go. So let's look at each one of these test values. First of all, like we said, the factor e to the x is always, or the function e to the x is always above the x-axis. So no matter what you plug in, e to that value is going to be positive. And so as I'm looking at all of these intervals, I'm going to be looking at all of the different factors, and that e to the x factor, no matter what I plug in, is always going to be positive. So I'm going to go ahead and put that positive there. Now, the negative 2 factor, the negative 2 test value, when I plug it into the other factor on top, the x minus 3, I get negative 2 minus 3, which is a negative 5. When I plug in the negative 2 to the factor on the bottom, I've got negative 2 plus 1, so that would be a negative 1, and it's negative. We don't care about the actual value, we just care about the sign. So now looking at all of the signs here together, we've got a positive times a negative on top, so that would be negative. And then we've got that negative on top divided by the negative, so negative divided by negative overall would be positive. Really what you're doing here is counting whether you have an even or an odd number of negatives. And here we have an even number of negatives, so they cancel each other out into a positive. Okay. Moving on to the next interval, we have the test value 0. When we plug it into the top, we've got 0 minus 3, which gives us a negative value. When we plug it into the bottom, we've got 0 plus 1, which is a positive value. And here we just have a single negative sign, so it's a negative overall. Moving to the 4, for our test value, we have 4 minus 3 is positive. We've got 4 plus 1 is positive. So everything there is positive, and we're talking about overall a positive sign. So the circled signs are the overall sign for each one of these intervals. So when we're doing our final assessment here, we have positive intervals starting at negative infinity, because that would be all the way to the left. And it's positive up until the tick mark there at negative 1. After that, we pick back up at positive, starting at the tick value of 3, and we are positive indefinitely at that point. So all the way to the right, so we go to infinity. It's negative there in the middle, and that middle interval goes from the negative 1 to 3. And so you see there, the entire number line is broken up into intervals of positive and negative, and there's no overlapping there. So we go from positive to positive and catch everything, except for those switchover places.